January 25th. Now, one thing I'm glad Tim reminded me. Thursday, there's going to be testing in this hallway for the rest of the week. You're not going to come here. You're going to go to the library. Okay? Thursday? Yeah, I think that's it. Unless I just didn't find my name on all the sheets they sent us. I think we're just being displaced on Thursday. Okay? Now, Friday, you're going to have a test on USUB. Okay? But you have two things on your desk now. You have the notes, day 66. And what else do you have there? Take home quiz. Now, yeah, I know, right? So now it's written. Now you shall be done. So the thing is, I'm not going to fit as much. I'm going to try, but I will not finish today's notes. So you're not going to be able to do the regular homework today, which means if I were you, I would do the USUB take-home quiz today because that's all you have, right? So it is, passing's optional. So, yeah. So if I were you, I would do that tonight. Now, when you do your take-home quiz, how do you check your answers? Somebody's just said online, hurt my feelings. Okay, so yeah, you take the derivative of your answer using the chain rule, and if you get back to where you started, you did it right. All right. So we have this. It's due Wednesday, and on Friday you're going to have a test. Today's lesson, day 66, is the last I'm teaching you, and then it's basically a review in between now and then. It's just that I'm not going to be able to finish today's lesson today. Got it? All right. So for the do now, I want you to, let's call it a you now. Isn't that funny? Yeah, that's a good one. It just came to me. It's a good one. Yeah, fill those in and see how many you can get. I'm not checking homework today because I feel a little rushed. I know, you're probably sad. All right, we're back. Gotta get this done here. All right, guys, so what's the antiderivative of du over u? Nice, Emily. All right, we're going underneath that. For some reason, this one always gets the kids. So, what's the antiderivative of u du? Yes? Nope. You were definitely on the right track, though. U plus c, so is the derivative of u plus cu? Whatever you tell me, if you take the derivative of it, you got to get back. I shouldn't hear any x's. You're right. You're just not being specific enough. I can't tell you. What do you think, Derek? Bam! Yep. 1/2 u squared. It's the power rule. You just couldn't see the power, so you got all confused. Right? You add 1 to the exponent, and yes, you were definitely right. But you said the whole n thing. I was like, no, you have to. Now, these are specific. Yeah. We see that, guys? It was just the power rule, where the power was 1. All right, what about the next one? Du over rad u. You probably read that online. No, put your hand up for a second. Oh, a question? Okay. Yep. It does start with a 2. Oh, man, that's good. Yeah, 2 in a row. Because this one was u to the negative 1/2 the u. So when you add 1 to the exponent, negative 1/2 plus 1 is positive 1/2. Then you multiply by the reciprocal of the new exponent. That's why there's a 2 here. So it's 2 rad u, or 2u to the 1/2 plus c. Power rule again. Woo! Cameron. Yes, but I'm just going to put the 2/3 up front. But you're absolutely right. You could put 2u to the 3/2 all over 3, or just do it like that. So yeah, this time you're integrating u to the positive 1/2. So again, you add 1 to the exponent. That brings you up to 3/2. You multiply by the reciprocal of the new exponent, which is 2/3. So 3 out of these first 4, the power rule. Huh. Let's go on to the other side, shall we? Antiderivative of du over u squared. What? Oh, that's all right. All right. That's his sneeze. Leave him alone. All right. Anyone know this one? Manny, sorry. Go ahead. Yep. Nice. Or you could write it as -1 over u. Yeah, right? You could write it like that also. Either way, as long as you can do it. Power rule. Because the power was -2. That's how we're getting that one. Adding 1 to the exponent, the new exponent. Oh, wait, no, not again. No, no. Yeah. Yep, e to the u plus c. That's what everyone wants. No, not e to the x. Ryan. Why am I saying Riley? I do that again, Riley. I do that all the time. I don't know why I do that. Sorry, Riley. Nice. Bam. Okay, what is this last one? Oh, u squared? Wait, I'm just looking for a newcomer. It's a few old comers. Something new, something different, exciting. Sydney. Yep. U to the third over 3, or you could say 1/3 u cubed. Let's see. Power rule again, right? You know, alrighty. These are nice. Now, I gave you the homework answers to check. So if you flip your page over, you'll see them. You'll have to check that and then just get back to me with questions you had, because I want to just keep going today. But one thing I do want you to check when you wrote down your answers, some kids were telling me, like in number 2, they wound up with 4 times 5 to the x in the numerator. And they multiplied. They made it 20 to the x. No. The PEMDAS police will get you, right? You can't multiply before exponents. So yeah, if you got to this point, then you leave it. You can't multiply because this is raised to an exponent here, right? It's just like with numbers. If you had 2 times 3 squared, 2 times 18 is... Oh, wait, that was a bad one to do. I'm going to pick a different one. I just take bad numbers. Let me see. Let's see. 4 times 3 squared. That would work. That would, okay. So what is 4 times 9? 36. If you tried to multiply first, 12 squared, that would be 144. You can see that wouldn't work. Oh, what are the chances that I would try to show you was wrong by so well? Yeah, so you just can't do that because of PEMDAS. Okay, now let's get into today's fun. So you'll look them over, but ask me questions tomorrow on that. Ooh. All right. Look for the teeny writing. You know when you have to integrate tan x, you have to rewrite it. Do you remember how you rewrite it? Sine x over cosine x. Nobody's going to tell you to do it. You just have to know. Because we don't have an integration formula for tan x, right? So, but if you write it as sine x over cosine x, how's that going to help you? It'll be u sub, and yeah, the bottom's the u. So it'll be a du over u. Same thing if you have to integrate cotan x. You can't do it. We don't have a formula. So you have to rewrite cotan x as, what goes on the top? Cosine x over sine x. Then, again, it'll be a du over u if you make the denominator u. And you might need to throw a negative in there, but that's it. Oh, that one you don't. Okay, well, just like you have to remember what to do for those, there's something you're going to have to remember to integrate secant x. Because we don't have an integration formula for secant x, do we? Well, it equals 1 over cosine. But so if you have to integrate 1 over cosine, then what? You'd be stuck. All right, so we don't know what to do. But thank goodness somebody at one point did know what to do. And I'm going to write something down. You're going to tell me why I'm allowed to do it. Right? Secant x plus tan x in the numerator. And in the denominator, right, secant x plus tan x. Yeah, we just multiplied by 1. Anything over itself is 1. So we are allowed to, because anything over itself is 1. So the antiderivative of secant x is equal to the antiderivative of secant x times this crazy form of the number 1. Do we agree? Let's distribute. Now remember, when you distribute, secant x is over 1. So let's make this nice, simple little antiderivative look complicated. So if we distribute the secant x, what do we have in the numerator? Nice. Okay, and what do we have in the denominator? Secant x plus tan x. Good. Wow. This is something we actually can integrate. I want you to look at the numerator and look at the denominator. Look at that with the big eye. See anything how this would help us? The antiderivative of secant x to tan x is secant x. That's true. Okay. So how does that help us? Yeah. Yes. Because if you make the denominator u, so make the u equal to secant x plus tan x, what does that make du? What's the derivative of secant x? Secant x tan x plus, what's the derivative of tan x? So for du, it would just be all that times dx. Secant x tan x plus secant squared x. We have that? Yeah. Yeah. So now when we rewrite this, the denominator's u and the numerators are du. So by multiplying numerator and denominator by the same thing, we were able to get the form so we could apply our du over u integration formula. And what is the antiderivative of du over u? ln of the absolute value of u. And then all we have to do is put the u back in. So the antiderivative of secant x is equal to the natural log of the absolute value of secant x plus tan x. That's the crazy one. Now, some people just like to memorize the answer. I like to memorize the process. You know, it's up to you. Yeah, you can. Like if you had to integrate cosecant, you do the same thing. You multiply by cosecant plus cotan over itself. So it's kind of cool to understand that. All right, now we're going to get to integrating, where we wind up with one of our inverse trig integration formulas. Yeah, these are the best. So before we get to those, I just want to see if you remember the derivatives of the inverse trig functions. Who remembers the derivative of the inverse tan of u? 1 over 1 plus u squared. And then since it wasn't just the inverse tan of x, it was inverse tan of, yeah, times u prime. I'm going to say times du dx. You can just put the u prime up top. So it was 1 over 1 plus u squared, or u squared plus 1, whatever you like, times du dx. So that if I was asked to find the antiderivative with respect to x of 1 over 1 plus u squared times du dx, you see that if the derivative of the inverse with respect to x of the inverse tan of u is 1 over 1 plus u squared times du dx, if you take the antiderivative with respect to x of 1 over 1 plus u squared times du dx, and you won't see those, so it'll just look like this, okay? What do you have to get? Inverse tan of u. Let's see. So we're going to hope, like, if we use some u substitution, if we can get it to the point where we've got this integration formula, we'll know what it is. Okay? Do you remember what the derivative of the inverse sine of u is equal to? Right. Times u prime. The u prime you could put up top, or you could put next to it. But we're using our chain rule. We're saying times the derivative of u with respect to x. So if we work it backwards and take the antiderivative of this side, and again, we'll just see the du, what do we know we have to get? Inverse sine of u. Let's see. Those are my two favorite inverse trig functions. The last one's just weird. Do you remember when we took the derivative? We had the one here. There was something weird going on outside. Absolute value of u. When you take the derivative, you got to put that there. And then u squared minus 1, and then you needed your du dx. So it'd be 1 over the absolute value of u times square root of u squared minus 1 times du dx. Now, when we work it backwards, we don't need the absolute value there. If you notice, this is just a regular old u. But we will have an absolute value somewhere. Gina? Yeah, that's where it is. So we get the inverse secant of the absolute value of u plus 6. It has to do with the domain. It gets too much. That one is the least used of these three. With the AP exam, it's usually the top two that are used. So if you look at these three integration formulas that I want to use with u substitution, they're all in the denominator. There's always a 1, and there's always a u squared. You see that? And this is going to cause us to have these 2 extra steps when we want to do u substitution to get to one of these. But then it'll just be like our old friend u substitution. But we will have 2 extra steps. And those 2 steps are going to be this. If the number down here isn't a 1, we're going to divide it out to make it a 1. We'll factor it out. And then we'll have to identify u squared first. We'll say, okay, u squared is whatever I see with the 1, and then I'll take the square root. So it's just these 2 little extra things you got to do. And we'll go through them. What do I have? So I have, oh, good, we're going to do it. We're not doing the derivatives. I already decided that. So these are the 2 extra steps. The number in the denominator has to be a 1. So if it's not a 1, we'll factor it out, make it a 1. And then we'll identify u squared before we figure out what u is and du and the rest. All right. So the first problem we have, we want to integrate 3 over 4x squared plus 25. Now, no matter what the type of u sub we were going for, what would you do first? Factor out that 3, right? We would do that anyway. Any constant multiple, we factor it out. If you had to guess right now, do you think this is going to give us an inverse sine, inverse tan, or inverse secant? Yeah, right, because that's the only one without a radical. That's the only one with a plus sign, right? So once you're thinking, okay, I'm going for inverse tan, you want the constant to be a 1. Right now our constant's a 25. So we're just going to, whatever is there, if it's not a 1, we're going to pull it out front. We're going to factor it out. And just GCF that right out of the integral. So out front, we had the 3, but we're pulling out a 25 out of the denominator. Can you guys tell me if I pull a 25 out of the denominator, I factored it out, I divided out, what I'm going to have in the denominator now? What was the first one? 4x squared. I pulled out a 25. So when you pull something out, all you're doing is dividing by it. Over 25. And then what's the 1, which is the reason we did it, right? Now, if you're not sure if you did that right, you can always multiply the 25 back, and you'll be right here, right? Factoring and multiplication you're doing, just going different ways. Okay, so that was my first extra step, making the constant down here a 1. The second extra step is just identify u squared. Whatever's with the 1, that's your u squared. So in this case, what is u squared going to be? 4x squared over 25. After this, it's all normal u substitution, because now you're going to say what u equals. 2x over 5, you just take the square root, right? And after we write down what u is, what do we normally do next? Du, right? So if u is 2/5 x, or 2x over 5, what is du? This is the same as 2/5 x, so what is du? 2/5. After we write down what du is, what do we usually say next? Before I change it over, what do I got to make sure I have in place? Du, the factors of du. So in between this integral sign and the dx, I need to have a 2/5, right? So we're going to multiply inside by 2/5. And then what do we put on the outside? 5/2. Now we're going to rewrite it in terms of u and du. What would the number outside be? 5/2 times 3/25. It'd be 15 over 50. Can we reduce that? 3/10? Not like that. So we have 3/10. And now, watch how beautiful this becomes. Look at that 2/5 times 1 times dx. What is all this? That's just du. Look at the denominator, the 4x squared over 25 plus 1. U squared plus 1. Ooh, that's pretty. Do we know what the antiderivative of du over u squared plus 1 equals? Inverse tan of u. So we have 3/10 times the inverse tan of u plus c. And then we just write 3/10 times the inverse tan of u is 2/5 x. So we're going to write 2/5 x, or 2x over 5. Do you like better? Plus c. Isn't that crazy? So it's a mess? Crazy, but crazy fun, right? Is that what you were going to say? Gina said crazy fun. Yeah, I really wanted to do this one right away afterwards, but I guess I'll wait. Because we're having a delayed opening, so we don't have much time today. All right.